Hey everybody, welcome to my physical world. This is the week of July. July 21st. What has been going on around the globe this past week, this past month, and even couple months? The Earth seems to be awake. Well, I have been asked quite a few times this week about what is going on, what's happening in Mount Rainier, what's happening at Campi Flegrei, what's currently going on in Kamchatka, all types of stuff. Well, let me put it this way. We live on an extremely dynamic planet. Of all the planets in the solar system, the Earth is the most dynamic. When you look at all the different factors, if you look at all the different planets, from Mercury basically being pretty much just a X-rayed rock in space, obviously being close to the sun, it's getting a lot of radiation, but it's dead. If we move out to Venus, obviously you have the CO2 clouds. There's volcanic activity on the surface of Venus, mainly due by pressures and heat. There could be some plate tectonics, but the jury's still out on that one. But it's a violent planet, obviously, being this almost roughly the same size as the Earth. But it's just not the same. Okay. And let's skip the third planet for now, and let's head on over to Mars. Mars might have had a life a long time ago. We obviously see evidence of that. We know that the planet at one time was covered with water just because of the geology and the erosion patterns and that kind of stuff. We know that it's had a violent past of volcanic activity. The Tharsis Triad shows that with the gigantic, monstrous volcanoes. Shield volcanoes, by the way. Much like the volcanoes of the Hawaiian Islands, pretty much the exact same thing. Yet, why is Mount Olympus Mons so gigantic? Well, you got to remember the mass of Mars is much lower. The atmosphere, the gravity is what, 1/3 of the Earth, so the vertical extent on Mars is going to be much greater. We look at other things that on Mars, such as the Mariner Valley being 4 or 5 miles deep. You know, largest canyon that we know of at the moment. I mean, it had a past. However, it's pretty much cold and dead now. We have a lot of rovers. Us, China, etc., have been exploring this little salmon-colored planet for quite a while now. We're understanding more about it each and every day. but it is not that active at the moment. And we move into our gas giants: Jupiter, Saturn, Uranus, and Neptune. Well, they're just that. They're balls of gas, very cold. They're large. Jupiter generates a massive amount of radiation, and its magnetic field is second only to the sun. But the gas giants are pretty much the same in terms of their variety of things that are going on. Massive wind speeds, clocked in some cases at 1,500 miles an hour. But like I said, it's their diversity is flat. Okay, there's only a few things that dictates their dynamics, right? Now, I'm not out here to you astrophysicists and stuff that are specializing in each planet. You're going to have your own view, and I understand that, okay? But in contextual arena, when you face the Earth, when you compare it to the Earth, there is no comparison in the diversity and of the dynamics of the planet. The Earth obviously is being pulled. It's being pushed. There's just a lot of dynamics that are going on. We live on a living planet. So our history has shown all this stuff, evidence of all these past catastrophes, all the different stuff that's gone on. Today, the past week, the past month, the past few months is no different, okay? We are, in some cases, probably a little bit more active than we've seen in the past. And let me talk about that for a couple seconds. Most of it, the reason that you're seeing all of this activity going around the globe is because the media is latching on to it. Let me give an analogy. Boeing, which is a polarizing topic, it's as polarizing as politics and religion. You have 50% of the globe that are pro Airbus, and you have 50% of the globe that are pro Boeing. Okay, that's just how it is. However, any time there is an incident, Boeing is under a microscope. I can tell you right now, Airbus, they may not have had the bad luck that Boeing has had with dramatic crashes and stuff, but every time there's an engine flame out, whatever it is, and it happens to be a Boeing aircraft, it's going to hit the media much more than it's going to be an Airbus. But I can tell you, daily, Airbus has just as many called emergencies around the globe as Boeing aircraft. And we can throw other companies in there too. Boeing has had a lot of bad luck, and yeah, they've had some bad problems with management and production in the past. Obviously, I'm not denying that. But the media is putting Boeing as a bad company in your face because their microscope is on that. That's the analogy. I'm not here to talk about Boeing and Airbus and all them. But that's the analogy of what's going on in the media with earthquakes and volcanoes. Okay? But if we look currently on the screen right now, this is the USGS site. These are all the earthquakes that have happened in the past 24 hours with a magnitude of 2.5 and above. Anything below that, they're so small, humans will not feel them. You'll be very stretched for a human to feel anything below a 4. Okay, you can feel them. Okay, 3.9s. Yeah, you can feel them, but it really depends on your geography. It depends on the geology that you're standing on top of. Okay, a 3.0 earthquake in the Great Plains of the United States would probably be felt more than a 3.0 being you standing on the Sierra Nevadas in California. It's because of the geology. Out in the middle of the continental United States, or North America, where you have the Great Plains, it's very sedimentary. It's looser, it's softer, okay? Whereas if you're standing on these big monoliths of granite in the Sierra Nevadas, you're not going to feel the shake as much, okay? So remember, depending on where you live, what you live on, determines what you feel with an earthquake, all right? So you're looking at the earthquakes that have happened in the past 24 hours. And I don't have, okay, I'm not zoomed out to Europe a little bit here, but you got some here in Greece and up here in Iceland, okay, down here toward Antarctica. But if you concentrate on this area, the Pacific Ring, which everybody calls the Ring of Fire, right? You can expect a lot of earthquakes every single day, because this massive plate, which is one of the largest plates on the planet, this is a big slab that's sitting there moving toward the northwest and kind of rotating. In California, they slide together. The North American and the Pacific plates slide together in a strike slip fault. But up here, especially with the activity that's been going on up here in Kamchatka, these are subduction zones. The Pacific plate is diving under these plates over here. Okay? Totally different geology going on. So you're going to get a lot of rumbling. You're going to get a lot of fractures. You're going to get a lot of earthquakes. And yeah, some of them are going to be pretty big. What was the last one? 7.4 off of Kamchatka. And then the other day, we had the 6.2 just south of Sand Point in the Aleutian Islands. Okay? But there is kind of a pattern going on. And we've seen it over and over. So this, as this plate is moving, it's going to fracture some rocks. It's going to disturb the crust of the earth, and it's going to generate earthquakes. Now, it might relieve some pressure in this area once this fractures, but that's going to lock up somewhere else along this ring, okay? And that's what we're seeing here is a while back, a few days ago, we had we had Sandpoint earthquake, 6.2. And then just over the past 24 hours off of Kamchatka, this activity is happening, all right? Now, after this probably calms down, we're going to have a fracture somewhere else around this ring. It could be down here in Chile. Okay, could happen over here in Indonesia. Could happen around Japan. All right. It's just that when you release pressure in one point of the plate, there's going to be buildup of pressure somewhere else on that plate, and then it's going to fracture and release that energy, and then it's just going to kind of go around this big circle. We've seen it constantly over and over and over. Okay. Now, some other things that have been going on are your volcanic eruptions. We'll get back to earthquakes here in a second. But volcanic eruptions, if you look at this map, all these red triangles, and there's a lot of them, these are volcanoes that are either currently erupting or have erupted in the past year. Okay? Currently, Kilauea is just a great dramatic show. It's a beautiful event. It's away from population, which is nice, but it's putting on a beautiful show. Okay, I mean these fountains are these lava fountains shooting out of Kilauea are reaching altitudes of 1,200 feet above ground level. Okay, very dramatic. But Hawaii is a hot spot. There's a hole in the plate. Okay, and that's why you have the Hawaiian Islands. Okay. Now, we got some elevated, the orange, we had some elevated event alerts for volcanoes along the subduction zones. Some of them are puffing, some of them are shaking. But that's pretty normal of what you would find in a subduction zone. There's nothing irregular about that. Okay. Indonesia down here. I mean, Indonesia has some of the historically most violent volcanoes in human history, or Earth's history. You got Krakatoa with the most famous eruption of 1883, which led to the lowering of Earth temperatures and all that kind of stuff, and from 1883 through 1886. And you also have Tambora down there. Tambora, which was much larger than Krakatoa in 1815. Well, that led to the year without a summer in 1814. 1816, sorry. It's a dynamic planet. These plates are constantly moving, tugged and pushed and pulled and all types of stuff. We're seeing a lot of activity in Iceland. Well, this is the conjunction of different plates, okay? You got the Mid-Atlantic Ridge. Matter of fact, the USGS map shows it better. But you have the Mid-Atlantic Ridge, where's the separation of plates, okay? And you have fractures coming off of Iceland all over the place. So Iceland has always been active for volcanoes, always. Indonesia, expect them anytime. It doesn't matter what season of the globe you're at, and I mean season as in historical season. Not summer, winter, fall, all that kind of stuff. I'm talking about seasons in time. Most of the most violent volcanoes, Indonesia has the most. Okay? Indonesia has the most active volcanoes on the planet. I mean, look at this line right here. Okay? And if you notice, they're red or they're orange. They're either erupting now or they're going to. Okay? There's probably a couple yellow ones in there, but this is, matter of fact, the most dangerous volcano that's on the planet right now is Krakatoa, because it is the junction of three major fractures in the Earth's crust. It's probably the most explosive one on a continual basis. Okay, I'm not talking about your super volcanoes like Yellowstone or Campi Flegrei, which we're going to talk about here pretty soon as well. But the Earth is dynamic. Nothing is out of the ordinary at the moment. Now, there's something I'm going to tag on at the end of the video, toward the end of the video, that I'm going to talk about, that can explain the uptick in things. Okay? But we'll get to that toward the end of the video. But the Earth is dynamic. It's always moving. I wouldn't have it any other way, because that tells us this is a planet of life. It's living and breathing. Both physical, geologic sense, it's living, and also life itself, plants, animals, humans, fish. Okay? Earth is dynamic. Earth is dynamic. Let's move over to Campi Flegrei. It's around Naples, Italy. Starts with an I. Over the past few months, they've been inundated with thousands of micro earthquakes, magnitudes 1 and less. And it is just freaking out people throughout the globe. Well, in a way it should kind of keep your interest. But the reason that it's in the news is because it's in the news. Earthquake swarms happen all the time. All the time. They're happening right now in Kamchatka. In the past, they've been underneath Mount Rainier, which we'll talk about here in a second. And they've been happening around Campi Flegrei, which is north and west of Naples, Italy. Okay, Pizzoli, Bagnoli, all that kind of stuff. Well, first of all, the attention to Campi Flegrei is because there's millions of people that live on top of it. Okay? Now, area is actually this bay right here. All of this area is a super volcano. It's just like Yellowstone, all right? But there's millions of people living inside the caldera. And that's going to move. It's going to inflate. It's going to deflate. It's going to have fumaroles. It's going to have earthquakes all the time. Okay, right now there's quite a bit of unrest going on there. Is it time to panic? No, there's not time to panic. The largest earthquake in this area in the past couple months has been a 3.9. Remember how I was talking about 3.9s being felt? Okay. Yeah, you would feel it here because the ground is relatively soft here. It's not like it's a big slab of granite. A lot of this is ash fill from ancient volcanoes erupting and all that kind of stuff. So you're going to feel a 3.9. But the majority of the thousands of earthquakes that have happened here are 1 and below. And yeah, there's fumaroles popping up here and there. There's places where asphalt is being turned back into its tar form. Okay, but it's doing what it's always been doing. The big thing is that there's millions of people that live on top of it. So there is no imminent eruption coming. Okay, and that's according to the INGV. Okay, that's kind of like Italy's version of the USGS. But it's noticeable because it's in the media. It's calming down now. It's slowing down. There's not as big of a swarm as there has been. These are a list of earthquakes in this particular area. And there's been 314 in the past 7 days. All right. Now, let's move to another topic that's been in the news. And it's because it's been in the news that people are freaking about. And that's Mount Rainier. This map shows 780 analyzed swarms, or not swarms, but earthquakes in this underneath Mount Rainier. This is not tectonic. This is not magmatic. This swarm is because this mountain, this large volcano, is covered with snow and ice. And we're having hot weather. Well, I don't live in this area, but there's hot weather. There's hot weather all over the globe. The Earth is warming. And I'm not saying climate change. Well, I just did, but the Earth is naturally warming. We're coming out of an ice age. Did you know that? And so the Earth is naturally warming. It's part of its 24,000, 26,000 year cycle. Okay, yeah, humans do induce some effects of localized climate. Humans do have an impact on the environment. Yes, they do. That you'd be silly not to believe that. But the Earth is in a normal, natural warming. There was a day. And insert your geologic time zone, time period here. There was a time when there were 0 glaciers on the planet. And then there was a time when there were glaciers all over the planet, ice sheets. And we're coming out of that time now. The Earth is going back to an era where there were no glaciers or ice on the planet. That's where the Earth is headed, because it was there before and it's going to be there again. All right. Now, Mount Rainier, back to Mount Rainier. So as all this snow and ice melts on this mountain, that water that doesn't run off as rivers and streams is going to soak down into the mountain, and it's going to get heated by the magma chamber that's underneath this dormant volcano. Dormant doesn't mean extinct. It means it's sleeping, but underneath this mountain there is a magma chamber. There is heat coming up. It's not active yet, but it will be eventually. Look at Mount St. Helens. All right. But that water that's on top of this mountain from the ice is working its way into the inner workings of that heat generator that's underneath Mount Rainier. And what happens is that water that gets in there is going to heat and expand. And that expansion, water, and especially water under steam, is unbelievably powerful. That heat, that steam inside the mountain is going to expand, and it's going to fracture rocks. That's what it's going to do. And it's doing it now. So during the summer months, you would expect volcanoes that have ice and snow on top, and that meltwater is going to work its way down, and it's going to turn into steam, and it's going to fracture rocks, and that's going to generate these swarms. Okay? All volcanoes do this that have ice and snow on them. Okay? That's what's going on in Mount Rainier. It's not magmatic. It's not magma moving. It's not getting ready to erupt. Okay? That's what's going on at Mount Rainier. So don't panic. Now, is this volcano going to erupt and affect the Seattle and Tacoma area? Someday it will. Yeah, it's a volcano. It's just sleeping right now. Okay? It's been what, maybe 1,000 years since it last erupted? Well, guess what? It's going to erupt again. Because this is still part of an active subduction zone. The Wandel-Fuca plate, which is subducting under the North American plate, that is what created the Cascade Mountains, the Cascade Range. And that is a subduction zone. Where you have subduction zones, you have volcanoes. All around that ring of fire. Okay? All around that ring of fire. Here's the Wandel-Fuca plate right here. And it is diving underneath this massive North American plate. And it has created the Cascade Range. Okay? Cascade Range right through here. Here's the subduction zone right here. Now, look how small the Wandel-Fuca plate is. Someday, this activity may stop because there's not much of that plate left. It used to be much bigger. But we still have this much plate to go before the activity in the Cascades ceases. Okay? This plate still exists. It's still subducting. Now, what's going to happen when the Wandel-Fuca plate completely is gone? We don't know. We don't know. We don't know what's going to happen to this plate boundary. Is the Pacific plate going to continue to slide under the North American plate? They don't know. Is it going to turn into a strike slip fault like it is in the San Andreas fault here in California? They don't know. It's too far in the future. It's too far in the future. The dynamics of the globe of this planet, you know, there is some unpredictability. But there's no reason to panic because you're listening to CNN or MSNBC or other silly media outlets. If you want to know the information, you need to go directly to the scientists involved at the USGS or the INGV. You know, they're not lying to you. They're using science, and they know what's going on. Back in the 1980s, when Mount St. Helens erupted, that extremely accelerated the knowledge, the geologic knowledge of volcanoes. That was the most studied volcano, and we got to do it live. And then we had in 92, we had Mount Pinatubo, which was, I believe, on the scale was a 6. Okay, Mount St. Helens being a 5. So it was up on the chart, and it erupted, and they got to study it. A little bit too close for some scientists. But the media is going to put things in your face every single day to get views and all that kind of stuff. But you need to actually follow the science by going to the sources, such as the USGS, the INGV, almost every major country in the world has their own geologic survey type of organization. Go right to them, get the answer. Are they right all the time? No, they're not right because it's science. Science fails more than it succeeds. That's just what science is. Remember, you gotta observe it, measure it, test it, and then repeat that process. And you're gonna have more failures than you are gonna have successes, especially in predicting earthquakes and volcanoes and that kind of stuff. Now, I am going to finish off by one other thing that could explain the uptick in some of this activity. It's not foolproof. Like I said, it's science. It's not foolproof. But you have scientists over here that say, yeah, it is. It can explain it. And you have scientists over here that say, no, it doesn't explain it. You have those over here that say it definitely explains it. And then you have some over here that people would call deniers, say, absolutely not, it doesn't. Okay? You got all these camps in science. All these camps. But it is science. Let's take a look at it. And that is space weather. Okay? This is spaceweather.com. This is when you can find out if you're going to see an aurora from the sun erupting. But we are in, right now, the peak of a solar cycle, the max solar cycle. We're in the peak. The sun has been more active in the past 4 years than it has in a lot of its cycles. The cycles of the sun is 11 years. Okay, you go from minimum up through maximum and then you go to minimum. It's a wave. It's an 11-year cycle. And if you look at this map, if you look at this list of sunspot days at spaceweather.com, you can see the pattern. Here's 2015, right here. 0 days of sunspots. That means the sun was very active. And if you look at the 3 previous years, it was active, very active. So you got 4 years of high activity, and then it starts to slow down. Then you get to the minimum, which happened in our last minimum was 2019. You had 281 days where there were no sunspots on the sun at all. Okay? Out of 365, plus or minus 1 day, right? So the sun is going through this cycle, 11-year cycle, and we are at the peak right now. Okay? In 2022, there was only 1 day in the year that it didn't have a sunspot. But then, bam, 3 years in a row, and we're currently in 2025. 2025 is not over yet, but no days. Every single day had a sunspot of some size or number of sunspots. Okay? And we are getting some massive sunspots in 2025. 2024 and 2025 have been some of the most active years on the sun that we have been able to see. But just like Earth, the sun has its cycles too, right? Now, this is going to end. The solar cycle is going to start to slow down again. Matter of fact, I wouldn't be surprised if we finish this year with at least 1 or 2 days that had no sunspots. But right now, it's very active. What am I getting at? What does that mean? Well, when you have the sunspots, that's when you're getting these mass coronal ejections. You're getting these flares, these X flares, and all this kind of stuff. When you're in the peak of its activity, that's when you're going to get a lot of this, and it's throwing all of this material, all of this sun material, to the Earth. Okay. Glazing blows here and there, but sometimes we get direct hits. But nonetheless, the Earth is getting bombarded by sun dust all the time in the maximum. Okay? And that could have effects of the plate tectonics. It's not conclusive. There's failures in the science and there's successes, but there could be a correlation between sun activity and earthquakes and volcano activity on the planet as well. Now, if we come down here, this is a image of the sun showing holes in the corona. So we have a large coronal hole here, and we have one down here. Now, what it's not showing is that the sun does rotate on its axis just like the Earth. Okay, so the sun has a day, but it's a lot slower. But each part of the sun does not rotate at the same velocity or speed. Okay, the equator, just like pretty much almost every planet that rotates, the equator is moving faster, but the sun is not solid, and so it gets twisted. Okay, and that magnetic field of the sun gets twisted, gets all these ribbons get twisted because the equator is moving faster than the material up here, And I don't mean, I mean, yeah, okay, let me try to explain this a different way. On Earth, if you're standing at the equator, you're moving relative to the stars about 1,000 miles an hour. Okay? And as you move up the globe, technically, you're not moving at the same speed. However, the Earth is solid, so you still have a 24-hour day. Okay? But that's not the case with the sun. The sun gets twisted, okay, as it's rotating. And so that kind of messes things up. And that happens, that's an 11-year cycle. And it produces these coronal holes. Okay? They're out of sync. These areas, their magnetic fields are out of sync. All right, and it's not really a hole, but it's a magnetic hole. Okay, so it's the same but different. I know I'm doing a horrible job at explaining this, but this area could be an area of huge coronal ejections of material. Okay, now the brighter areas are areas where you have sunspots and things, and they are erupting. But these coronal holes, matter of fact, it has turned now. It's on the backside now, but this whole bottom part of the sun is this massive. On the other side of the sun now is this massive coronal hole. Okay, and when those are facing us, all bets are off. Okay, I'm probably not really explaining that all that well, but let's take a look at the sun with its sunspots. Remember those bright areas of the sun in that last image? Well, these are sunspots. And these are locations of difference in magnetism, but these are areas of eruptions. Okay, so these are where you're going to get your flares, your CMEs and things like that. Well, it's very active on the sun right now, and that could be one explanation of the increase of earthquakes and volcanic eruptions. Okay, but then it's science. It may not be related, and they're still studying it. Okay, so I know this has been a long, drawn-out video, but I just want you to understand your planet. That's the goal of My Physical World, is getting you to understand even the elementary mechanics of this dynamic planet. It's kind of like, it's so dynamic and so complex. You can't just say one thing is causing all this stuff to happen. All right? It's no different with climate change. You cannot say, if you understood the Earth's atmosphere and all the different things that go in to make this atmosphere what it is, the models, weather, okay, all of this stuff, it is so complex that one little item cannot explain it all. So, CO2 in the atmosphere caused by humans, you can't say for 100% that just because we have increase from vehicles and factories that it's doing it. You cannot be a scientist and say you have one cause. It's too complex. I'm sorry, it's just too complex. I've been a scientist for 40 years. It's way too complex to blame it on one little variable. Yes, humans have impacted the environment. I do not deny that. The LA basin is disgusting. It's just this mass of concrete. A Mediterranean type of weather pattern, a climate pattern, has turned into this inferno. Well, look at all that concrete in the LA basin. It's just one massive slab of concrete and asphalt. It's going to create a heat island. It's going to upset the local climate. So when you say that the LA basin is a Mediterranean type of climate, you can't say that anymore because of all the asphalt and concrete that humans have put in that one spot. A long time ago, that area was absolutely gorgeous in terms of its temperatures and rainfall. It was absolutely gorgeous. And then we just laid down a huge slab of concrete and put buildings on it, and then we introduced the automobile to it. So localized climate change, yes, it does happen. But you cannot spread that one thing all over the globe. It just will not work. Science doesn't work that way. So, yeah, you can't blame definitely can't blame earthquakes and volcanoes on climate change, like a lot of people are doing. Oh my goodness sakes. That is probably the least amount of that is the lowest variable to consider when you're talking about earthquakes and volcanoes, and people are out there doing that. Politicians are doing it. They're blaming geophysical stuff on human induced activity. It is ridiculous. It is not that. So I just ask you, as a listener to this channel, to just understand the elementary information about how this planet works. If you understand just the elementary components of Earth, you will understand that there are other things happening. Okay? The Earth is warming. It is. It is warming. It warmed years and years and years and years ago, millennia ago. It warmed, but then it cooled, and now it's warming again. It's proven by science. It is. We are going through a cycle. Now, if you are in an area like LA and you're tired of the global warming, okay, localized warming, move. So, yeah, this was quite a lecture, talking to you like I'm your parent or something. I don't mean to do that. I just want you to understand the elementary workings of this dynamic planet. Anyway, if you guys want me to focus in on a certain topic about this, let me know in the comments. I don't mind if you disagree with me. I do not mind at all. That's how science works. We can have you can comment. Just be kind, be professional, be human. Well, don't be human sometimes, because humans act horrible to one another. But be considerate. in your comments. I don't mind you putting up your comments and your point of view. I'll read it. There's nothing wrong with that. That's what we're here to discuss on this channel. But I hope you guys find all of this useful. I know it's been a long video, but I hope you enjoy it. Hope the information is useful and it makes you dig deeper. Okay, go out there and learn for yourself what I'm talking about. Go to the sites, go to the scientists that are actually studying this every single day. Don't just listen to, don't listen to the media at all, to be honest with you, or the mainstream media. Okay, there's a huge revolution going on in media, and the best information is coming from, and I'm not saying I'm one of them. Okay, by the way, I'm not saying I'm an influencer at all. Okay, because I'm not. I'm just some old man sitting up in his room looking at science and having fun with it. But look at all the different YouTube channels and podcast people that are scientists that are creating a new type of media. Get away from that mainstream media crap. Your news networks. Get away from the BBC, from ABC, from CBS, from MSNBC and CNN and all that garbage stuff. Find a new media. Okay? Support their channels. Support their podcasts. Get the science from the scientist, not from the media. Okay? Because every media is biased. Every mainstream media is biased. They have their own agenda. Don't give in to it, okay? Because that's what makes science look bad. They're the ones that have turned science into a religion, okay? Look for the truth. Find alternative sources of media, okay? Anyway, I've babbled on for a long time on this Monday morning, and I hope you guys have a great week. I hope you guys share this video, subscribe to this channel, buymeacoffee.com/myphysicalworld. That'd be great. And anyway, I'm an artist, by the way. Now, I'm a retired scientist. And if you want to see some of my oil paintings, go to ChristopherDO.com or Christopher Do Art on Facebook. And I will see you guys on the next science video. We'll see you later.